The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, folks, so here's what's going on. Your final exam is 1 week from today. It's on Monday, let's see, I need to change the calendar here. Monday, the 7th of December, and you need to finish it by 11:59 p.m. on that day. I believe you have about 3 hours to take the test. You can take it anytime from now until then, but once you start it, you have to finish it. You can't go in and work on it and then come back 3 days later. So just be sure that when you open it, you are ready and you aren't going to have any distractions. My plan is to do the following. Today, we're going to review the material that you used for test number 1, which was over section 3.7, 4.5, and then 14.1, 2, and 3. Tomorrow, we'll review material from chapter 8, Wednesday, chapter 9, Thursday, chapter 10, and Friday, chapter 11. So that's what's going to happen this week. And I will pretty much stick to that unless people ask other questions once I'm done. In other words, like if you want me to go over some things from chapter 11 today, I'm happy to do that. But after I've covered whatever material I want or other students want me to cover from the first test. So there you have it. Let's get started. So back in section 3.7, we dealt with graphing linear inequalities. The first thing I want to talk about is solving an inequality and remind you of what you need to do. Basically, solving an inequality is just like solving an equation in that you can add the same quantity to both sides of the inequality symbol. You can subtract the same quantity from both sides. You can multiply both sides by the same number. You can divide both sides by the same number, as long as you don't multiply or divide by 0. You can clear fractions by multiplying both sides by the least common denominator. You can clear decimals by multiplying both sides by a power of 10. Everything's the same, except if you multiply or divide both sides of an inequality by a negative number, then and only then do you change the direction of the inequality symbol. So let's say, for instance, we had negative 3x less than 15. To solve this inequality for x, we would divide both sides by a negative 3. Because we're dividing both sides by a negative, we would change the direction of the inequality. Let's say we had negative 2/5 x is greater than or equal to 20. Here, to solve for x, we would multiply both sides by negative 5/2. So on the left side, we get x. On the right side, we get negative 50. Oops. But we would change the direction of the inequality because we multiplied or divided both sides by a negative number. Any questions about that? All right. Then I'm going to go to a different screen and do some graphing. So let's see here. Okay, 5, oops. And what do we got here? 10 and 5 and negative 5. Let's say we have the inequality 5. Seriously, is it going to do that to me today? Oh, I guess I didn't get it clicked. There we go. I checked this last night. Everything was working fine. But I think I just didn't push the button hard enough. Okay. We'll find out. There we go. 5x plus 4y is greater than or equal to 20. Now, there are two different methods that we looked at to do this, and I'm going to cover both methods. The first method is the method that I prefer, just because I think it's easier, but not everybody agrees, and that's just fine. What I'm going to do, I'm going to take this inequality and I'm going to put it in slope-intercept form. So I'm going to solve it for y. So my first move is going to be to subtract 5x from both sides. So that would give me 4y greater than or equal to negative 5x plus 20. Then I'm going to divide each term on both sides of the inequality by 4. So I get y greater than or equal to negative 5/4 x plus 5. So now this is in slope-intercept form. The slope is negative 5/4, and the y-intercept is 5. Any questions on that? Feel free to stop me at any time if you have a question on something I'm doing. Okay. All right, so graphing that, I'm going to start by graphing the y-intercept, which is at 5. The slope is negative 5/4. So going from left to right, I'm going to go down 5 and over 4. Down 5 and over 4. All right. Now, I need to draw a line through that. Okay, so there's my line. But I need to consider, is the line solid or dotted? Well, because it included the equals, it includes a solid line. If it just had greater than or less than, it would be a dotted line. Now I need to decide which side of the line it's on. Well, having solved it for y, it says y is greater than or equal to, so it would be above the line. So the solution would be the solid line that I've drawn and everything above it. Any questions about this example? All right, I'm going to go back and solve it a different way. Now we're going to solve it by finding ordered pairs. Let's see here. We'll get rid of all of this. Actually, let's just do this. Extend that out. Extend that up. And okay, so let's consider the equation 5x plus 4y equals 20. So we're going to look at the equation. We're going to find a couple of ordered pairs. I'm going to go ahead and find the intercepts. Okay, so looking at this equation, if y is 0, I would have 5x plus 4 times 0 equals 20, or 5x equals 20, or x equals 4. So the x-intercept is at 4, 0, which is right there. Finding the y-intercept by setting x equal to 0, I would get 5 times 0 plus 4y equals 20. So 4y equals 20. Divide both sides by 4, and y equals 5. So 0, 5 is the y-intercept. Now, going back and looking, the original inequality did include the equals. So that means that we are going to draw a solid line. Okay. Now, we need to determine which side of the line to shade. So I'm going to pick a test point, a point that is not on that line. I'm going to pick 0, 0 because that's an easy point to plug in. So I'm going to choose 0, 0 here. Okay. And I'm going to plug that into my original inequality. 5 times 0 plus 4 times 0 greater than or equal to 20. 0 plus 0 greater than or equal to 20. 0 greater than or equal to 20. That is not true. So it's not on that side of the line. It's on the other side. So my graph is everything above and including the solid line. Any questions about this particular example before we go to another one? All right. So now we're going to go on to section 4.5. Now, in section 4.5, what was different is that instead of just graphing a single inequality or linear inequality, we're going to be graphing a system of linear inequalities. So we'll be graphing more than one. But each one will be done in much the same way as the one we did before. All right. So let's say we've got the following: 2x plus y greater than or equal to 3, and x minus 2y less than or equal to -1. Now, I'm going to go ahead and use slope-intercept form. If anybody wants me to use the finding the points method, I'm happy to do that. It just takes longer, but I'm happy to do it. Just if you want me to do that, let me know, okay? All right, so I'm going to take this first inequality, the one that's written in black, and I'm going to solve it for y. So I'll subtract 2x from both sides, and I get y is greater than or equal to -2x plus 3. So the slope is -2, and the y-intercept is 3. So y-intercept of 3, slope of down 2 over 1, down 2 over 1, down 2 over 1, etc. The original inequality includes an equal sign, so I'm going to draw a straight line through that set of points. Let's see here. That should be good. And since it says y is greater than, we're talking above the graph. So there's the graph of the first inequality. Now I'm going to go back and take a look at the second inequality. I'll subtract x from both sides. -2y less than or equal to -x minus 1. I'm going to divide both sides, each term, by -2. Because I divided by a negative number, I'll change the direction of the inequality. And let's see, this is going to be what? 1/2 x plus 1/2, I believe. So the slope is 1/2, and the y-intercept is also 1/2. Let's see here. Okay, so we're at 1/2. We're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2. Notice I'm going up 1. So from here, which is 1/2, I go up to 1.5. That's up 1 over 2, up 1 over 2. Okay. Now, this is also including an equal sign. So I'm going to draw a straight line, a solid line rather, through that. Okay. And it says y is greater than, so we're talking above. So our solution, I'll make our solution green, would be everything. And again, the red and the black lines extend on infinitely, but there's your solution. Okay. Does anybody want me to go back and solve these using finding the points method? If so, speak now. All right. Do you want another example of solving a system of inequalities, or should I go on? Anybody want another example of this?
Yes, please.
Yes, please. All righty, we'll do it. So let's go to the next page. And let's see here. How about 2x minus 3y less than 0 and 2x plus 3y greater than or equal to 12. Okay. And we'll make a graph. So I'm going to take this first inequality and put it in slope-intercept form. I'll subtract 2x from both sides of the inequality, giving me negative 3y less than negative 2x. Then I will divide both sides by negative 3. So I get y on the left and positive 2/3 x on the right. Because I divided both sides by a negative number, I changed the direction of the inequality symbol. This is now in slope-intercept form. The slope is 2/3 and the y-intercept is 0. So plotting the y-intercept at 0, going up 2/3, up 2/3, up 2/3, etc. Now, my inequality does not include an equal sign. So that means that the line I'm going to draw should be dotted. Okay. It says y is greater than, so we're going to be above the dotted line. All right, next up, the red inequality, 2x plus 3y greater than or equal to 12. Let's see if we can make that 3 a little bit easier to read. So here, I'm going to subtract 2x from both sides of the inequality, 3y greater than or equal to negative 2x plus 12, divide each term on both sides by a positive 3, so I get y is greater than or equal to negative 2/3 x plus 4. So the slope is negative 2/3 and the y-intercept is 4. So the y-intercept is right there. The slope is down 2/3, so right there, right there, right there, etc. It says y is greater than or equal to, so I'm going to draw a solid red line. Let's see if I can get rid of that and do a little bit better job of that. Maybe I'll just use the graphing tool. It's off a little bit. That's a little bit better, I think. Okay. And it says y is greater than or equal to, so it's solid and it's above. Let's see, if I extend this line up there a ways, and then let's go with green again. Our solution is where the two graphs overlap. So this is solid along here, dotted along there, and then everything above there. All right, Any questions on this example? All right, are we good to go, or do you want another example?
I think we're good now.
All righty, then that takes us to section 14.1. And I'm going to go back to the other screen. Okay. Can everybody see that okay? I'll take that as a yes. 14.1, and we're going to talk about factorials. Recall, for instance, 5 factorial looks like 5 with an exclamation mark after it. 5 factorial equals 5 times 4 times 3 times 2 times 1, which would be 20, 60, what, 120? But you could also write that as 5 times 4 factorial, right? Because 4 factorial would be 4 times 3 times 2 times 1. Or you could write it as 5 times 4 times 3 factorial, etc., etc. Okay, so let's take a look at some examples. Let's say we have 13 factorial over 10 factorial. Well, rather than write 13 times 12 times 11 times 10 times 9 times 8 times 7, etc., over 10 times 9 times 8 times 7, etc., we could do this. We could write 13 factorial is 13 times 12 times 11 times 10 factorial, because the 10 factorial represents the 10, 9, 8, 7, 6, 5, etc. And then we could have the 10 factorial in the denominator. All right. And then the 10 factorials would reduce, and we would get, let's see here, pull out my calculator, and we've got 13 times 12 times 11 is 1716 over 1, or 1,716. Any questions on that particular problem? Okay, let's take a look at another example. Let's say we've got 5 factorial over 3 factorial times the quantity 5 minus 3 factorial. So the first thing I think I would do is simplify inside the parentheses. 5 minus 3 is 2 factorial. So now we've got 3 factorial times 2 factorial. Well, what I could do up top, I could take 5 factorial and write it as 5 times 4 times 3 factorial. And then leave the 3 factorial in the bottom as it is. And then 2 factorial would be 2 times 1. Now, why did I do this? Because now I can come back and I can cross out the 3 factorial on the top and the bottom. I can reduce the 4 over 2 to 2 over 1. And I've got 10 over 1, or just 10 is my final answer. Any questions on that one? All right. Let's take a look at another example like that. Let's say we've got 6 factorial times 7 factorial over the quantity 8 minus 3 factorial times the quantity 7 minus 4 factorial. First thing again that I would do is I would simplify inside the parentheses. 8 minus 3 is 5, so this is 5 factorial. 7 minus 4 is 3 factorial. So I think I would take, let's see, I could take the 5 factorial out of either the 6 factorial or the 7 factorial. I'm going to take 6 factorial and write it as 6 times 5 factorial. Okay. 7 factorial, I'm going to take the 3 factorial out of that. So 7 times 6 times 5 times 4 times 3 factorial. So what I did here is I took 6 factorial and broke it down so that I could get rid of that. I took 7 factorial and broke it down so I could get rid of that. Okay, so now I've got, let's see here, 6 times 7 times 6 times 5 times 4, which is 5,040. Any questions on that one? Okay, recall that if you didn't have a calculator and you were using an online calculator, if you go, let's say we've got a problem like this, 16 factorial, okay? Rather than on your calculator go 16 times 15 times 14 times 13, etc., we can go to Google, and I'm going to type in Factorial Calculator. And when I do that, let me show you the different screen there. So I just typed in Factorial Calculator, and let's see, this X with an exclamation mark button would be the factorial button. And I want 16 factorial. Now, what is that E? This is 2.092279 times 10 to the 13th power. So 2.092279 times 10 to the 13th power. So let me go back here. And there would be your answer. Any more examples needed on factorials? All right. Then we're going to go on to the next section, which is 14.2. And we're going to look at arithmetic sequences. The formula for that was this: A sub n equals A sub 1 plus the quantity n minus 1 times d. Recall that the little subscript refers to which number in the sequence we're dealing with, and d refers to the common difference in an arithmetic sequence. All right, let me do some examples here. So let's say we've got this. Write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. Okay, let's see. We are told that the first term is 8, and the common difference is -5. And we are to find the 25th term. So first of all, the general instructions said to find the first 5 terms, and then we're supposed to find the 25th term. Okay, since the common difference is -5, that means that we are going to add -5 to each term to get the next term. So 8 plus -5, let's see here, 8 plus -5 would be 3. 3 plus -5 would be -2. -2 plus -5 would be -7. -7 plus -5 would be -12. Okay, now I could keep going and find the 6th and the 7th and the 8th and the 9th and the 10th, but that's way too much work, and that's not how I want you to do it anyway. To find this term, A sub 25 would be A sub 1, which is 8, plus n minus 1, n is 25, minus 1 times the common difference, which is 5, excuse me, which is -5. So this becomes 8 plus 24 times -5, which is 8 plus -120, which is -120. 12, I do believe. So there's the first 5 terms, and there's the 25th term. Any questions about that example? All right, let's take a look at another example. Here it says, write the first 5 terms of the arithmetic sequence with the following properties. The first term is 5, so a sub 1 equals 5, and the 5th term is 29. And we wanted to find the first 5 terms, so we need all of this. We know the first term is 5, and the 5th term is 29, so we need to fill in the 3 in between. Again, we're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. We know a sub 1 and we know n, but we don't know d yet. So a sub n would be what? 5. So a sub 5 would be a sub 1, which is 5, plus n minus 1, which is 5 minus 1 times d. So we've got a sub 5 equals 5 plus 4d. But we also know that a sub 5 equals 29 because it's given. So a sub 5 equals this, and a sub 5 equals that. So our equation becomes 5 plus 4d equals 29. Then if we subtract 5 from both sides, 4d equals 24, divide by 4d equals 6. 5 plus 6 is 11, plus 6 is 17, plus 6 is 23, plus 6 is 29. And there we have our 5 terms. All right. Any questions before we go on to another example? This says, insert the given number of arithmetic means between the numbers. So that is numbers that are equidistant from both ends. Here it says, put in, let's see here, 3 arithmetic means between 20 and 80. Okay. So if there's going to be 3 arithmetic means between 20 and 80, that means our first term is 20. Then we've got 3 arithmetic means in the middle, and our 5th term is 80. Okay, because we want 3 in the middle, we've got 1 at both ends plus 3 in the middle is a total of 5. Now the problem is basically like the last problem. A sub n equals a sub 1 plus the quantity n minus 1 times d. A sub 5 equals 20 plus 5 minus 1 times d, which is 20 plus 4d. So a sub 5 equals 20 plus 4d. But a sub 5 also equals 80. So this equals that. 20 plus 4d equals 80. Let me stop there for a moment in case you're frantically writing this down. Any questions about what I did? Same thing I did on the previous problem in terms of filling in for the variables. Subtract 20. 4d equals 60. Divide by 4d equals 15. 20 plus 15 is 35. Plus 15 is 50. Plus 15 is 65. Plus 15 is 80. So there's your 5 terms. All righty. Now we're going to go on to section 14.3, which was geometric sequences. And the formula for that is a sub n equals a sub 1 times r to the n minus 1 power, where r is called the common ratio. And the terms are separated by multiplying rather than by adding. Okay, let's see here. It says find the specified term of the geometric sequence with the following properties. the first three terms are, it says 2, 6, and 18. Find the seventh term. Okay. Now, to find the common ratio, we take a term divided by the previous term. So what is 6 divided by 2? 6 divided by 2 is 3. Just to make sure, what's 18 divided by 6? That's 3. So the common ratio is 3. Okay, so we know now that R equals 3. Now, again, we could take 18 times 3 and then times 3 and times 3, but we're not going to do it that way. We're going to just plug it into the formula. So a sub 7 would be a sub 1 times 3 to the 7 minus 1 power, which would be 2 times 3 to the 6th power, which would be 2 times, let's see here, 3 to the 6th power is 729, and that times 2 is 1,458. So a sub 7 would be 1,458. Any questions on that? All right, let's see here. It says, write the first 5 terms of a geometric sequence with the following properties. Let's see. The first term is 2, and it says that R is less than 0. So it's basically telling us that R is a negative number. It also says the third term is 50, and we're supposed to find the first 5 terms. Okay. Well, let's see here. We've got some holes in our thinking there, don't we? We could take the formula a sub n equals a sub 1 times r to the n minus 1 power, and we could use a sub 3, which is a sub 1 times r to the 3 minus 1 power. So a sub 3 is 2r squared. But we also know that a sub 3 is 50. So basically, we know that a sub 3 is 2r squared, and we know that a sub 3 is 50. Therefore, 2r squared equals 50. Divide by 2, r squared equals 25. Take the square root of both sides, and we get r is plus or minus 5. But wait, they said r is negative, so therefore r equals negative 5. 2 times negative 5 is negative 10, times negative 5 is 50, times negative 5 is negative 250, times negative 5 is positive, what, 1250? So there you have that. Okay. Let's see here. Any questions? Oh, all right. This says, find the geometric means to be inserted in each geometric sequence. Insert 4 geometric means between 3 and 96. So we've got a sub 1 is 3. Then we're going to find 4 of these means in the middle. So then a sub 6 is 96. Okay, so you got 4 in the middle, 1 on each end, total of 6. We're going to use the fact that a sub n equals a sub 1 times r to the n, r to the n minus 1 power. So a sub 6 equals 3 times r to the 6 minus 1 power, which is 3r to the 5th. So a sub 6 equals 3r to the 5th, but a sub 6 also equals 96. So this equals that. 3r to the 5th equals 96. Divide both sides by 3. R to the 5th equals 32. take the fifth root of both sides, and we get r equals 2, because 2 to the fifth power is 32. So the fifth root of 32 is 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. And there you have it. Okay, let's take a look at one more example. It says, find the geometric mean between 2 and 128. So a sub 1 is 2. It says we've got one geometric mean between them. So a sub 3 is 128. All right. So a sub n equals a sub 1 times r to the n minus 1 power. A sub 3 equals 2 times r to the 3 minus 1 power. A sub 3 equals 2r squared, but a sub 3 also equals 128. So this equals that. 2r squared equals 128. Divide both sides by 2. R squared equals 64. Take the square root of both sides. R equals plus or minus 8. Now, unlike in a previous problem where it specifically said that r was negative, there's no, it doesn't tell here. So basically, let's see here. Got to find the right spot. Okay. Somehow, hang on. It appears that I've made a mistake, but let me see. Find the geometric mean between 2 and 128. Okay, 2, 3 minus 1, 2 squared divided by 2 is 64, plus or minus 8. Oh, I see. I was looking at the answers and it doesn't give, it gives the geometric means, but I was looking at that thinking that was the answer. That's the common ratio. If we use the positive 8, this would be 16. If we use the negative 8, this would be negative 16. There we go. I was right with my calculations, just it's Monday. You know how it is. I thought I made a mistake. Turned out I didn't. All right. Well, there you have information from the first test. So tomorrow we'll be looking at chapter 8. So, and also I'll be back this afternoon at 1:15. And other than that, have a great rest of the day. And
Mr. Mayo?
Yes.
So we have to wait until the 7th to take our exam, or can we take it before?
No, you must have come in late because I didn't announce that at the beginning of class. You can take it any time from now until then, but once you start it, your time starts, you have to finish it. So you can't do it a little bit at a time, but you can take
thank
it
you.
anytime. You bet. All right. Stop the recording.